Hi everybody. My name's John, and I'm going to try and give you a little information today on wood burning science, wood burning appliances, fireplaces, chimneys, clearances, and maybe help you out a little bit on what to look for when you're doing an inspection with a wood burning stove. I just want to qualify that I know most of you are probably in the United States. I live in Canada, up here on beautiful Vancouver Island. And a lot of the stuff that I'm going to say during my presentation is going to be Canadian regulations. So, I encourage you to find out, who the regulatory bodies and who governs in your particular area. Some of the dimensions and rules that I'll give you will be ours, but bear in mind that a lot of the technical stuff when it comes to wood burning installations, stoves and chimneys, is governed by the manufacturers anyway. So, wherever that stuff is made, manufacturers put out installation guidelines, and the manufacturer's installation guidelines always, at least in Canada, supersede the code. So having said that, let's just, get into it here. I don't know whether this, there we go. So a cute little picture here, just to indicate that, man has been, working with fire and controlling fire or attempting to control fire and heat from fire, since caveman days. And it's probably, safe to say that without fire and the energy from fire, we might not even exist as a species. So, we've made obviously lots of advancements from this, but this is where it started. So what I'm going to try and convey to you today is what you see on your screen. In Canada, we have what is known as wood energy technology transfer, which is or WET as we call it, which is a body which actually trains inspectors to become inspectors of specifically fireplace installations, wood burning installations, and chimneys. I'm not sure what you have in the United States as far as this is concerned. One of the advantages that we have up here is that all of the codes across our country are the same. So we don't have specific codes for each individual province, although each province can put additional requirements. So there are a lot of codes that apply to wood burning appliances, and I'm not going to cover them all here. And I'm going to kind of breeze through this part of it because a lot of it, is regional. All right. And then as far as legalities are concerned, what exactly are we responsible for when we inspect a house that has a wood burning appliance in it? And that again is going to vary with where you live. And then I'm going to get into the real thing that I'd like to get through to you today, which is the science of fire and why clearances are so important. These are just the levels of inspections that we have here in Canada. So we'll just kind of skip through these. And these are some of the misconceptions that people have about getting a wood burning installation inspected. So none of these things can you get, because what WET does really is just train inspectors. I think we went through that already. I don't know whether this is actually going to work in this format or not very well. patient with me here. Okay, here we go. So depending on where you live, standards or codes that apply will be different. Here in Canada, when you have a masonry chimney or a masonry fireplace, it's our National Building Code, Part 9. So wherever you are, you would want to know what code actually applies. When it comes to factory-built chimneys, the codes and the installation is determined by the manufacturing codes. So this is a collection of manufacturers that get together and write these. And here in Canada, we also have the Canadian Standards B365 code and also manufacturing codes when it comes to wood burning appliances and flue pipe assemblies. Okay, I think I'm going to do this a different way here because it's giving me a hard time. Okay, so what are the responsibilities as a specialized inspector and a home inspector? So when you're doing a home inspection on a home and you see a wood burning fireplace, it's kind of similar to doing a home inspection on a home and looking at, say, an electrical panel. Well, you're not an electrician or an electrical inspector. However, you want to know some things about that electrical panel so that if you see some glaring safety issues, for instance, you're going to want to tell your customer of those. So we have this responsibility to our customers, especially when it comes to their safety. And there are obviously a number of issues, when it comes to the safety of installation of wood burning appliances and fireplaces and chimneys. So, where that line is in doing an inspection, is kind of fine. But one thing for sure, you don't want to go do an inspection where there's a wood burning appliance and miss an obvious safety issue because you're setting yourself up now for some legal action. So what I hope today is to try and give you a better idea of what it is that you're looking for when it comes to the safety. All right, so let's just get into the science of what's going on here. And I'm going to get a little bit technical here as to, what exactly happens when you burn wood. So the actual scientific term for the process of burning wood, and we're just going to stay with wood for our topic today, is called pyrolysis. And pyrolysis is a thermal chemical decomposition of an organic material, so in our case, wood. So we all remember this from our, grade probably 9 or 10 science, the 3 ingredients that are required to create fire. So first of all, we need fuel. And here it says oil, but in our case, we're talking about wood. We also need to apply heat to the fuel. And in order for the reaction of fire to happen, there needs to be oxygen. So these 3 things are necessary. Take any one of them away and you don't have a fire. Okay, so what happens in the process of burning or wood or pyrolysis of wood? So here we have a diagram, and if you look at the one on the right-hand side labeled A, you'll see that we have a piece of wood. The wood is made up of molecules, and we're applying some external heat to that wood. So that external heat could be coming from pretty much any source. And then as we apply the heat, so if you look at this picture B, what happens when we reach a certain temperature, and that temperature is surprisingly low, then what happens is the molecules of the wood start to evaporate, if that's the right word, or volatilize into the air. Okay, and when those molecules enter the air, then pyrolysis has begun. And what happens with those molecules is when they get into the oxygen part of the air, they will react with the oxygen. And the reaction of those molecules with the oxygen produces heat. And as heat is produced, then more reactions occur. And then more heat is produced and more reactions occur, which sets off a chain reaction. And this is what happens when we burn a piece of wood. And that chain reaction then accelerates. And as it accelerates, the gases and tars that are trapped in the wood start to ignite. And this is what we see as flames. So this is the process of burning, and this is what's happening. And this is really important thing to think about, especially item B, you know, when we're talking about wood that's buried inside walls. And we're going to get to that in a minute and let you know why this process of pyrolysis is important to understand. So here's a picture of a wall with some studs behind it and some drywall in front of it. And what you can see here is we're applying a heat source to that wall. So the surface of the wall can appear normal, but the wood in behind the surface of the wall can be actually experiencing pyrolysis or starting to burn and charring, depending on the temperature. So that process starts at about 190 degrees C and can be happening in behind the surface without knowing. So this is the reason that we have clearances on appliances. And we're going to talk a little bit about how those clearances are determined as we go on here. So, you know, when you think about the temperature of where this starts, you might want to relate, just to make it more realistic, where about 140 degrees is where you can hold your hand. So this is where wood is just getting, you know, above that part where you temperature where you can actually touch. Okay, and here on the left-hand side, you can see an example of wood that was behind a finished surface that has began to char. And then the picture on the right-hand side is a pretty devastating picture of what happens when that process is allowed to continue on, which of course is what we don't want. So where do most fires come from when it comes to wood burning is actually in the chimney itself. So the appliances themselves, as long as they're built by a reputable manufacturer and have been certified, are usually not the cause. The cause, although appliances can cause the pyrolysis to happen inside a wall and the fire can start there, most times fires are started by chimneys. Okay, and you know where this happens is in a chimney fire. So I'm gonna just, you know, take a minute here and say, you know, this picture of a chimney or inside of a chimney shows you that, you know, what happens inside a chimney is you get a soot buildup, and that soot is also composed of tars like creosote that come from the wood, which gets encapsulated or trapped by that soot and then collects on the outside of the chimney or the chimney flue. So then a spark from the fire landing on this very volatile, sooty buildup inside the chimney can start a chimney fire. And just for a minute here, I'd like to talk about, you know, where does this soot buildup come from? Well, wood is comprised of cells, and the cells are encapsulated, so they actually trap water inside the cell. So when we cut down a tree in the forest that we tend to use as firewood, that tree and the wood that's composing the trunk of the tree, which is what we want to use, has cells that contain water. So in order to use that wood, like say we wanted to use it for construction materials, we need to remove the water from the cells of the wood, which is called drying. So when we take wood and cut it down and use it to build houses in construction material, we remove the water from the cells of the wood to a percentage. 19% is about where we want construction lumber. So when we build a house, about 10 or 11% is where we want wood when we wanted to use it for furniture or flooring or that kind of thing. And the reason that we want to remove that wood is because, or water, sorry, is because when we remove the water from the wood tends to shrink and check and crack. So we want all of that over with before we put it into a building, because we don't want it shrinking and checking and cracking in our walls or in our dining room table, for instance. Okay, so similarly, when we cut wood down for firewood, we want to remove that water. So if we take the wood, cut it down while it's still alive and try to throw it on a fire, what we're doing there is trying to burn what we call green wood. So green wood is wood that has just been cut down out of a live tree and still has all the water content in the cells, and none of it has been removed. When we burn green wood in a fire, a few things happen. So first of all, the water that's in the wood needs to be evaporated or boiled out of the wood in order for the wood to burn. Because we all know, and I've always found it kind of ironic that, you know, water being, you know, a combination of hydrogen and oxygen, which are both hydrogen being volatile and oxygen being a requirement for fire. But when you combine the two and get water, you get fire's worst enemy. But when we have wood encased in, or sorry, water encased in the wood, then the wood doesn't want to burn. And the reason it doesn't want to burn is because we have to boil that wood off, that water off, in order for the fire to have enough heat to burn the rest of the wood. So if you go back to your science again from high school, you'll remember that in order to boil water that last degree, so we heat water up to 100 centigrade or 212 degrees Fahrenheit, and we want to boil it, that final degree at 100 degrees centigrade or 212 degrees Fahrenheit takes about 6 times the energy that it takes to boil at 1 degree previously. And that's because we have to evaporate or boil that water and change its form. So we're changing it from a liquid into a vapor. So that process of boiling the water robs our fire of the heat, which means we now have what we call a cold fire, which is not completely burning the products in the wood. So the creosote and the chemicals and the fiber in the wood is not getting completely burnt because the fire is burning cold, because we're robbing the heat by trying to boil off that water. The other thing that happens when we're burning wet wood is we're creating steam. So the steam going up the chimney carries these unburnt items, if you want to call it that, like creosote and bits of wood or soot, and carries them up the chimney, and then the steam then condenses on the side of the chimney and leaves those deposits behind. So if you burn very green wood in a chimney, you can soon build up like a very sooty, chemically tarry substance on the side of your chimney in a hurry. And here's a couple of chimney fire pictures. And here's a couple of pictures of chimneys that have been burnt with green or wet wood. and you can see the amount of creosote and sooty buildup that gets inside the chimney. So here's the issue with this. When a fire is burning clean or you're using nice dry seasoned wood, very little of this deposit will occur in your chimney because all of the wood and the deposits in the wood is being consumed by the fire. But when you burn wood that is green and not seasoned properly, then you develop this. So in a normal situation where you're burning some nice dry seasoned wood, the temperature in the chimney itself is usually around 300 to 400 degrees centigrade, Celsius, which is normal temperatures. However, when you get a buildup such as this, and this creosote buildup, sooty creosote buildup on the side of the chimney catches fire, you have what is known as a chimney fire. So if we go back here, sorry, here, you can see this picture on the left, the chimney, the creosote inside the chimney is on fire. And that is gonna cause excessive heat and cause what's going on the right. So when you have a chimney fire, that normal temperature of 300 or 400 degrees inside the chimney will escalate to around 1,500 to 2,000 degrees. So you can see it's a significant difference. So what's important here when we talk about chimneys is that the chimney itself needs to contain this fire. If the chimney itself cannot contain this fire, then the picture on the right is what's going to happen. Okay, so how does a chimney contain a fire? Well, the chimney contains a fire by having a sealed flue inside the chimney. And if you look over here, you can see the flue pipe sticking up. So there's various types of flues that have been used. This is a masonry chimney that have been used throughout history. Clay flues, concrete flues, and in today's world, metal flues or stainless steel flues, and then also what we call factory-built chimneys, or chimneys which have their outer metal encasement and an inner flue. So these chimneys should be designed to contain these chimney fires. I don't know, Shancy, maybe we could stop there if there are any questions so far.
I just had a couple of, someone made a comment early on in your discussion, I guess, regarding what organization regulates chimney safety, and it's called, for the US, it's the Chimney Safety Institute of America.
Okay. Good.
And then I had someone else ask, do you use wet forms, and have you incorporated them into your HomeGauge report?
Okay. The first question obviously is just some information, which good to know. But what I have done in my software is I have actually developed a whole report writing template for wet inspections. So I use the HomeGauge software for wet inspections, and I can incorporate, that way I can incorporate pictures with the arrows for clearances. And I think later on you'll see a couple of pictures that are taken out of my report writing software. But I took the time to create a whole, one of the things I love about HomeGauge is I could recreate a whole wet report writing template, which is really cool.
Yeah, it's amazing how you can customize it. Although I will say, if the wet form is a PDF form of some kind that you create outside of HomeGauge and it's going along with a regular report, I'm not sure if that's how you typically do it, but you can attach it to the report pretty easily. And I think we might have a wet form. Do we have a wet form? Did HomeGauge create that wet form in our PDF? Let me see. It would probably be a fee related. I remember there being discussion about it.
Yeah, I don't use the wet form at all. I just do a complete report with all of my items, just the same way I would report on a house.
Okay, excellent. And I don't think we have, that's the only other question I had. So you can just keep on moving on, mister.
Okay. Okay, so we talked about that. And here's a couple of masonry chimneys and the kinds of things that you see. If you look at the chimney on the left, you'll see that there's no liner whatsoever. And this was common practice, you know, back 30s, 40s, and into the 50s. There were lots of chimneys that were built without a liner at all. This is a very dangerous chimney. But when you're using a chimney like this with an open, regular open masonry fireplace, it'll probably function fairly well as long as you don't have a chimney fire in it. I wouldn't want to have a chimney fire in either one of these chimneys. But the problem that happens here is people then want to get themselves a wood stove and pipe it into a masonry chimney. When you pipe a wood stove into a masonry chimney, you're now escalating the heat in the chimney, and these chimneys would not suffice. So these are things that when you inspect a house with a masonry chimney that you really want to look for. And, you know, I find that, you know, without specialized equipment, I do have a chimney camera that I can drop down the chimney and inspect it all the way down. But if you take your camera, and if you have a camera with flash, and stick it down the top of the chimney, if you can get the chimney cap removed, and take a picture with your flash, it will light the chimney flue all the way down to the bottom, and you'll get a pretty good picture of what's going on down the chimney. So, you know, if you're just a regular home inspector and you're not actually doing, you know, a technical chimney inspection, you still want to know if these conditions exist, especially, you know, if there's no liner, and also if the flue liner, like the one on the right-hand side here, is cracked. Because what's going to happen if you get a creosote build like we saw in the previous pictures in this chimney on the right, the fire that is created, if there's a chimney fire happening, is going to shoot through those cracks in the clay liner, and that's what's going to ignite the wood behind the chimney. So let's just think back now to the pyrolysis, and I'm just going to scroll back here, picture that we had here. And if you can envision now that these 2x4 members, these wood 2x4s, which have been in a house maybe for 20 or 30 years, that are nice and dry, if they're in contact or with this particular chimney here, in the framing members around the chimney. So what's happening to those pieces of wood that are in contact with this chimney, and this chimney in particular, is that they're heating past that point where the pyrolysis has started. So in other words, they have begun to burn. One of the most common arguments I get when I call things like this out on inspections of chimneys is, well, it's been that way for 30 years, so, you know, what's the problem? Well, that argument itself is even self-defeating, because if it's been that way for 30 years, then that wood in behind those chimneys has been overheating for 30 years, and pyrolysis has begun. So if you were to tear that chimney down and look at that wood, it's very likely all charred. So what's happening now when you're having a regular fire with your significant other with a bottle of wine on Christmas Eve, it's probably fine, because the temperatures are in around that 300-400 degree mark, and the wood itself, even though it started to pyrolyze, is not getting hot enough. However, let's say now all of a sudden in that chimney you have a chimney fire. Well, all of that dry wood that's in contact with these chimneys, that's just sitting there ready to explode into flames, is going to do exactly that, because the chimney temperatures inside these chimneys is going to escalate up to 1,500 degrees or 2,000 degrees. It's just kind of like having that nice dry piece of wood sitting beside your campfire that's been heating up for an hour, and then you put it and pick it up and throw it onto the fire. It just explodes into flames. And that's what happens when you have a chimney fire. with the wood that's in contact with the chimney. So regulations as far as clearances are concerned become really important, and you can see why. So we're going to talk about clearances and why clearances are important and how we can manage them. So when we think about clearances, we need to think about how heat gets transferred. Heat gets transferred in 3 different ways. It gets transferred by radiation. So radiation is when heat is radiated through the air in a horizontal plane. So when you've got your fire burning and you're sitting in front of it, the heat that you're feeling is conducted to you through the process of radiation. The next way it's transferred is conduction. So heat is transferred also through solid materials by a process of conduction, which transfers the heat through, say, something like a stone or a brick. So when you go back to this particular picture here, you know, the heat that's getting transferred will get transferred through these stones and through the brick. And it's important to note that it's easier and faster for heat to transfer by conduction than it is by radiation, because air doesn't transfer heat very well. That's why clearances and spaces between things with an air barrier, especially if there's a draft, you know, will not transfer the heat, whereas solid materials such as stone and brick will. So putting a brick liner, for instance, over top of a wood wall, you know, a lot of people think that that's protecting the wall, but it's actually accelerating the process of conducting the heat through to the combustible materials behind it. And then the third way that heat gets transferred is by convection, because we know that hot air rises. So, and this is how we create draft up our chimney, for instance, is by the hot air rising up the chimney, which then creates a draft up the chimney, and heat is then transferred by convection. So here's an installation of a wood stove. You know, this looks pretty nice. However, you know, what are the possible issues here? Well, most codes and most manufacturers, and I believe in the United States, in front of the stove, you would need 16 inches of floor protection. So, and in Canada, we would need 18 inches of floor protection. You can see here that this doesn't have that protection in front. So that's a clearance requirement of both the code and the manufacturer. And that clearance requirement may and may not be on the label, and we'll talk about manufacturer's labels in a minute. What we don't know here is, because we can't see the label, is what the clearance behind the stove would be. And then we also need to consider that this brick or stone wall that's behind there, what's in behind that stone wall? And we're going to talk about that in a little bit. For the most part, and our code in Canada here requires 8 inches of floor protection on each side of this stove. So, you know, it appears that the sides, as far as the protection on the floor is concerned, is acceptable. However, even though this, when you look at this walking through a house, you might think, oh, that looks pretty good. But if you know what these clearances are supposed to be, then you can say, well, wait a minute, you know, this is an unsafe installation. All right, so when we talk about clearances on a wood stove, such as the one we just looked at, this is a picture taken of how wood stoves are actually tested. So when, you know, company ABC Incorporated decides that they're going to manufacture wood stoves, then they need to get, and they come up with their design and they build a prototype, then that particular stove needs to be certified by somebody. these are the testing agencies that, this is not all of them, these are the more important ones, or the bigger ones that some of you may already know. Warnock Hershey, which is in Washington State, I believe. Underwriters Laboratory, who has testing laboratories pretty much throughout the United States. There's an Underwriters Laboratory Canada. There's Canadian Standards Association, and there's OMNI or OTL. So these companies would take a stove like this, and they would put it in an enclosure like this. So when you look at this picture, you'll see these dots on the wall here. And these dots on the wall would indicate thermocouples or heat sensing wires, which will tell them how hot the wall is in these locations. So what's done here with the appliance is a stock or set fire is built inside the stove, so that and you know, it's a certain pile of dry fir firewood stacked a certain way so that each stove is burned with a very similar fire. And then what's done is the temperature on the wall on the side and the temperatures on the wall in the back, etc., is measured, and the stove is moved away from the walls until a safe temperature, and I believe it's 190 degrees C, is determined, and then that becomes the clearance for that specific stove. So for instance, if the stove was tested with the stock fire and it had to be 6 inches away in order for the wall to remain at a safe temperature, then the clearance from that particular surface of the stove to that wall would end up being 6 inches. And then that would be put on the label, which is affixed to the back of the stove, and we'll get to that in a minute. So when you're looking at a stove, and one of my biggest pet peeves is that the manufacturers tend to put these labels on the back, and they're 6 inches away from the wall, so they become very difficult to read. But you know, there are tricks. You can stick your cell phone in behind there and take pictures of the labels, and then you know, look at the picture and expand it with your fingers and get into what the actual clearances are. So I would encourage you as a regular home inspector to, first of all, search for the label, because technically speaking, a wood stove without a label is uncertified. And most insurance companies will not insure a house with an uncertified wood stove. And the clearances for uncertified appliances are huge. If you go to the code, they're like 4 feet all the way around it. So in other words, you'd have to have your stove in the middle of your living room for it to be safe. So you want to at least check and see if there's a label. And then if you can read that label, you'll see the clearances. And I have a couple of pictures down here of labels that we'll get to in a minute. Okay, but this is how the clearances for the stove are determined. The flue pipe, which is this pipe, so, or the flue or connector pipe, which goes from the stove to the chimney, clearances from flue pipes here in Canada, and I'm not sure what they are in the United States, but for an uninsulated flue pipe or just a bare metal flue pipe, it needs to be 18 inches away from all combustible materials. So now bear in mind, if this is an uninsulated flue pipe and it's only 10 inches away from the wall, and the wall is covered with brick, that brick is not what you're measuring to. What you're measuring to is the combustible material behind the brick, just like the brick wasn't even there. Okay, so that's very important. Unless the brick is spaced off and is built as a shield, which we'll get to in a minute. Okay, so we covered that. Okay, so here's a few diagrams showing you where, you know, and clearances are important in stoves. You know, so we have the height clearance, and the codes here in Canada are 6. So this A here needs to be 60 inches. So that's 5 feet from the top of the stove to the ceiling. And then the clearances from the side and from the back need to be whatever is on the manufacturing label. Most stoves will have a corner clearance. So when you have a stove in this kind of installation, you measure from this corner to the wall, and on the label will be a corner clearance. Now this picture here shows a wall shield, and wall shields can give you reduction in clearances, and we'll talk about that in a minute. So here's a couple of examples of manufacturer's labels. So if we can like blow this up a little bit. So that what you'll see here is a table. So this is sidewall, back wall, and corner installations. So this is using a single wall connector. So so the clearances are going to vary depending on what type of connector or flue pipe you're using. So you can see here that the sidewall for this particular stove is 19 inches, and the back wall is 17.5 inches using a single wall connector. And using a double wall connector, the sidewall clearances are the same, but notice that the back wall clearance is significantly less by 5 inches, and the corner clearance is significantly less. So if you go into a home where they're using a single wall connector and the clearances aren't adequate, one of the suggestions you can make is to change the flue pipe out to a double wall connector, and then you may be able to meet the clearances. So you'll also notice that on these labels, I'll get that back down, there's other important information that the manufacturer is going to put on there. And this label is what rules. So in other words, what the manufacturers put on their labels here is what you need to follow. If the manufacturer's label says something that doesn't agree with the code, the manufacturer's label will override the code. At least that's the way it is here in Canada. That may be different in different jurisdictions, but the reason for that is because that's the way the stove has been tested. Okay, so these are actual pictures out of my out of reports, and this is showing you some clearance issues. So this one on the right here is kind of interesting because this is a fan blade from a ceiling fan. So depending on where this fan blade stops, you may and may not have a clearance issue. This is a single wall flue pipe, and that you can see that the clearance when measured to this wall surface here is only about 6 inches, 6 or 7 inches. So remember that this wall here, even though it's a non-combustible material, we're needing to estimate the thickness of that material and then add it to that particular measurement. So, and then we're assuming that in this picture, and I believe that it was, that the wall in behind this was combustible. So what we're measuring is through that non-combustible material to the combustible material behind it. Very important to remember that. Okay, and here's another clearance issue. So this is an actual factory-built chimney going through a wood ceiling. And even though these factory-built chimneys, metal chimneys, were originally called zero clearance, there's no such thing as zero clearance when it comes to wood burning installations. And all manufactured chimneys are basically 2-inch clearance unless they have a radiation shield around them. So this clearance here is only about 1 1/4 inches. So this wood is, in this case, is too close to this chimney. So what's going to happen in that wood as it gets heated up from the chimney? So on this edge here, pyrolysis is going to start to occur. And then if it gets heated hot enough, or we have a chimney fire and the temperature escalates, then this wood right here is going to catch fire, or could. So here's a picture of an actual metal factory-built chimney, and this is installed correctly. So you can see here that they have cut where this goes through the roof. What you're looking through here, these are the trusses. This is the roof sheeting. You're looking up into the cone of the flashing on the outside. And you can see that the wood has all been cut back away a good 2 inches from the chimney. So this is the way it should be. And then this is the same chimney going through the attic space down into the second floor. And you can see that this has a radiation shield around it. And the process of this radiation shield here is to keep the space. This is the chimney, this is the shield. And this is so that you could actually blow this insulation right up against this shield, and this shield would maintain the spacing from the combustible material, because the insulation is considered to be a combustible. So, and then this deck here is what we call a fire stop. So wherever a chimney transfers from one floor to the other, because you need to have the 2-inch space around it, then you need to have a metal fire stop so that if there's a fire starting on one floor, it can't transfer through to the other floor. And that's what we call a fire stop. All right, so we're going to talk just a little bit about masonry chimneys here, and I'm probably going to run out of time here. So just quickly, masonry chimneys are a whole nother ball of wax. And according to our code, or our building code here, interior chimneys, so a chimney that's classified as an interior chimney in a building, needs to have 2 inches of clearance from the masonry to any combustible wood framing around that chimney. And an exterior chimney needs to have a 1/2 inch. And those spaces need to be filled by metal fire stops. Okay, so here's the actual code. And it's interesting over here to say that how they define interior and exterior chimneys. So an exterior chimney can be considered to be one that has at least one surface exposed to the outside atmosphere or unheated space. So that could be attic space, which is unheated, over the majority of its length. So that's kind of vague. You need to really, you know, if I'm unsure, I just call it an interior chimney just to be on the safe side, and require the 2 inches of clearance. And here are the clearances here that are required to masonry chimneys. And here's a couple of pictures from actual inspections, and these are out of my reports, that show you that this wood, and this would be an interior chimney, is right up against the chimney. So again, the heat from the flue of this chimney is going to start to radiate through to this wood and start the process of pyrolysis that we talked about earlier. And then that wood is going to be drying out over the years. And then in the event you have a fire inside the chimney and the temperatures escalate, again, you have that same issue of that wood possibly starting to burn, which we don't want. So, you know, when you're in an attic and you're looking at a masonry chimney that's servicing a wood fireplace, you really want to check around there and see if they've maintained the proper clearances from the chimney to the wood. And here's a couple of other instances. This one, the insulation is in direct contact with the chimney, so there's no space there and there's no fire stop evident. And I would go down with my hand there and dig a little bit and see if there's any fire stop down there. And here you can see again, the wood is right up against the chimney. And here's another example. So you can see that I can take these pictures, you know, and put them into my wet inspection report and put arrows, you know, thanks to HomeGauge software. Okay, so here's a couple of innocent looking fireplaces. I think it's really important for us as inspectors to instruct people on fireplace use and, you know, what works and what doesn't work. So open masonry fireplaces are no good for heating a house. As a matter of fact, they'll take more heat out of the house than they'll put into it, because the only heat that you're going to get from these fireplaces is radiant heat. And because of the draft that you're creating here up these chimneys, what you're actually doing is sucking the air out of the house. So if you have another heating system in this house that's struggling to heat the house because this fireplace, there's so much draft going up these open chimneys that you're losing the actual heat out of the house. And then when this fireplace is not on, traditionally the dampers on such fireplaces are pretty leaky. They're just usually a metal shutter that closes, doesn't properly seal, because there's no way to put seals in there. You can't put rubber seals in there, obviously, they'll just burn. And so then when this fireplace is not in use, you know, you have the same convection of the heat going up the chimney, which is robbing the house of its heat. So, you know, people think sometimes, oh, it has a fireplace, so I can heat my house. Really, that's not going to happen. I always tell them what this is good for is Christmas Eve with a bottle of wine and your significant other and hanging your stockings around it. That's about it. So here's an interesting wood stove installation that I'd really like to talk about, because this really illustrates how deceiving it can be. This is the actual stove inside the house, and it has some tile on the wall. And this is the actual chimney outside. So what we need to think about is that this chimney here is 16 inches wide, and this stove here is 30 inches wide. And so if we go down to here, here's an actual cross-section diagram of what's actually going on here. So here's the wood stove. And if you can look down here, you'll see that it's actually 30 inches, 24 inches, sorry. And then if you look at the chimney outside, it's actually 16 inches. So when you look at this picture, that's not really very evident. You would have to go inside and outside to determine that. So what ends up happening here is, because this stove is actually, let's see, 8 inches wider than the actual masonry chimney outside, you have 4 inches right here that is radiating heat through this surface and into the 2x4 framing up the side of this chimney. So the actual clearance on this stove on the manufacturer's label was 24 inches. And what you had here was 9 inches to the tiled surface, and the tiled surface was about 1/2 inch thick. So you had 9.5 inches of clearance from the back of the stove to this wood stud right there inside the wall. And the requirement, or the safe testing of this stove, dictated 24 inches. And when I called this on the inspection, I had a huge argument from the owner of the house that this was perfectly fine because there was a radiation shield here on the wall. But that does not comprise a radiation shield. So let's just talk a little bit about what a radiation shield is. This is an uncertified appliance. We already talked about that a little bit, and we don't have time to get into that. But when you apply a non-combustible shield to a wall, you can actually reduce the clearances. And these are code issues. So your codes, wherever you are in your particular area, may be different. And I'm just going to show you what our codes allow. So this is a radiation shield. Now, notice a couple of things about this shield. First of all, it has an airspace at the bottom. It has an airspace at the top, and it's mounted on standoffs away from the wall. And that's so that air can go in the bottom and up behind the shield and come out the top. And that's what gives you the cooling effect of the wall. So when you take this shield or this material and actually put it right on the wall, and you have no air behind it, then you're not getting any reduction in heat. And then here's a detail of how that would look. So you have a non-combustible shield mounted on a channel standoff, and this is mounted about 1 inch away from the wall. And then there you have your airspace on top. You can also do this with brick. And here's an example of a brick wall shield. So this has air spaces in the bottom. The brick is built away from the wall, and then it has air spaces at the top so that the air can travel up behind the brick and come out the top. And then this would give you some reduction. And here's some examples of the kind of reduction that you would get in a shield. A brick shield constructed like the one we just looked at would give you a 50% reduction. So if the label on the back of the stove said that that stove had to be 12 inches away from the wall, and you built this kind of shield on that wall, then that stove would only have to be 6 inches away from the wall. So these are ways that people can move wood burning appliances closer to walls and get some reduction. And then with certain constructions, you can get up to 67% reduction in the actual clearance. But these shields have to be built to the standards. Okay, and then we get to actual chimney installations. And here's a good picture of an actual chimney installation and chimney bracing. Most of this requirement for the height of chimney bracing in a factory-built chimney is determined by the manufacturer of the chimney. So if you were to go onto Selkirk Chimney's website or ICC Chimney or any of the other chimney manufacturers, you will see that they will have their requirements. The code requires that anything higher than 5 feet above the roof in a metal chimney needs to have braces. Our building code here in Canada requires that any chimney greater than 12 feet above a masonry chimney needs to have braces. And then the height of a chimney is also governed by manufacturers of chimneys and by codes. And there's 2 rules when you determine if a chimney for a wood burning appliance is high enough. The first rule is the chimney has to be 36 inches above the highest point at which the chimney comes in contact with the roof. So if it's a sloped roof, and that would be on the upside of the slope to the top of the chimney. And that's not to the top of the chimney cap, that's to the top of the actual chimney. It needs to be 36 inches. And it needs to be 24 inches above the closest 10-foot structure. So that's kind of what that all looks like. Right, so when you're looking at a chimney on the outside of the building, that's what you need to be determining. So if you have a chimney that's down at the bottom of a slope, then you need to measure across 10 feet, and the chimney needs to be, so across 10 feet, the chimney needs to be 2 feet higher than that point right there. Okay, so I think we're out of time, and I kind of got through most of it. This is a longer presentation, normally would have more time, so I don't know if there's any questions or if I have time to answer questions.
I think that you really, everybody, you kept like 60 people engaged in this really interesting topic. John, I really appreciate all I mean, obviously you are an expert in this field, and what an amazing amount of information. Thank you so much for sharing your knowledge with us today. It is 5 o'clock, and is it okay if people reach out to you if they have questions?
Yeah, let me just, I'm open to questions. There's my information. This is my website, and this is my email. Anybody that has, anytime they want to talk, there's my phone number there. If you want to give me a call or email me with a question, I'm absolutely open to answering questions for people.
Excellent. Thank you so much.
On my website as well, as far as this is concerned, and what is entailed in home inspections and wet inspections.
Fantastic. Oh, we may have a question. 1 second. This person said, someone said, we don't inspect wood burning stoves, but this was very interesting. So I'm so glad we were able to offer such interesting topics. We had a great turnout today. Every single attendee, I mean, it was amazing how everyone was engaged. John, I learned a lot. It was amazing. All right, well, if anyone has any questions, you can reach out to John. This is the last session for this track. Thank you so much for attending. This was probably one of the most unique, amazing experiences I have ever had. I can't believe we managed to pull it off. We had great people.
Thanks for putting it on.
Oh, thank you so much for participating. Everybody, have a great night. Let us know if we can help you. You can reach out to us on Facebook, on support.homegauge.com. There's a chat feature, or support@homegauge.com if you have any questions. Thank you so much for attending. Y'all have a great night. Good night.
Good night. Thank you.
Bye.